Hi everybody. This video is on Rolle's theorem and the mean value theorem. So there are two theorems that I'm going to cover. First is Rolle's theorem. Um, if a function is continuous on a closed interval and differentiable, and they have the same y values within an interval, then there's a point between those two, a point between that interval where the slope equals zero. In other words, when slope is zero, you either have a peak or a valley, right? So if if we have 2 points where the y value is the same, then there's a spot where the slope, where the first derivative equals zero. Or you could do like this. If we have 2 points, do you see? And if we have it on an xy plane, the y values are the same. So we know there is a point, horizontal tangent line, where the first derivative equals zero. That's what Rolle's theorem says. And oftentimes the examples show you that the x-intercepts are the same y values, or y0, but it doesn't have to be an x-intercept. It could be any two y values that are the same. There is a point between those two where there is the slope of zero, where there is a horizontal tangent line. Okay, so let's show an example of this. Find two x values that show the first derivative equals zero at the same point and some point between them. So first of all, to find the x-intercepts of this function, we would factor it. And this factors the -2, -1. And if we factor it and set it to zero, then x minus 2 equals 0 and x minus 1 equals 0. Take the 2 to the other side, take the 1 to the other side, and you get x equals 2 and you get x equals 1. So what we have here is some form of a parabola where we have an x-intercept of 1 and we have an x-intercept of 2. And I don't know how low it's going. It doesn't matter to me. But we want to know, do you see how these x-intercepts have the same y value? The y equals 0. Do you see? There's one coordinate that's 1, 0. The other coordinate is 2, 0. So they have the same y value of 0. So what Rolle's theorem says is, if you have 2 points on this graph and they have the same y value, somewhere between them there's a slope of 0 somewhere, and you can picture it out. It's right there. You can draw a horizontal tangent line and the slope is 0. All horizontal lines have a slope of 0. Well, to find, and right here, this is what it's telling you. So let's take the derivative of our function. So f prime is 2x minus 3. If I take the derivative of this, I bring the 2 in front and I subtract 1. Here, I bring the 1 in front and I subtract 1, and the x goes away. This is the derivative. If I set this derivative equal to 0, right? Derivative is the same thing as saying the slope. If I set this slope equal to 0 and I solve for x, I get x. I take the 3 over, and then I take the 2 over, add 3 and divide by 2. I get a positive 3 over 2. So at x equals 1.5, on the graph at x equals 1.5, that's where my slope equals 0. My first derivative or my slope equals 0. That's Rolle's theorem. And it doesn't have to be an x-intercept. Like I said, you can do the same thing. I mean, you can do the same thing on a graph. If you had a graph like this, and you had a y value, you had a y value here and a y hat. Do you see how you have two y values of the same? There's a point between those two graphs where the slope equals 0. That's what Rolle's theorem says. Not too bad. I should try another example. Maybe well, we're fine there. Hopefully everybody understands that. That's Rolle's theorem. Now, the next one is the mean value theorem. It's a lot of people get them confused, or it's very similar to Rolle's theorem. The mean value theorem, this is a little messy, but the mean value theorem says this. It's a little different. Let's say I have a function that looks like this, and we're talking about endpoints. If I draw a line between those endpoints, and find the slope of this line, wouldn't you agree, if I have 2 points in algebra, we were able to find the slope of that line. And this was how you found the slope of the line. And I'm going to put it over here. F of b is the same thing as y2 minus y1 divided by x2 minus x1, right? It's the formula for slope when you have 2 points. So I have 2 points. I just need the coordinates, right? X of the first point, y of the first point, x of the second point, y of the second point, and I can find the slope of this purple line. That's algebra. Well, the mean value theorem says if you have 2 points on a graph and you know its slope, somewhere between these 2 points on your graph, there's another point that has the same, let me see if I can draw. There's another point that has the same slope. You see that the lines are parallel. So whatever this slope is, the slopes are the same. That's what mean value theorem says. You can take the average of these 2 points, which is the slope. If you find the slope between those 2 points using algebra, we can then, using calculus, find the slope at 1 point, somewhere between those 2 points. If we move along on that graph. You see, this is the derivative. That's the slope using algebra. This is the slope. Oh, that's the slope using calculus, the f prime. And this is the slope using algebra. So that's the mean value theorem. If you have 2 points, you can find the slope using algebra. Somewhere between those 2 points, you'll have another slope that's exactly the same, parallel lines, but you're only finding the slope from 1 point. So let's try an example here. And I apologize for the way that for some reason it didn't convert correctly. Once again, this is the calculus way of finding slope. This is the algebra way of finding slope. So, and this is very basic graph. The function is x squared. X squared looks like this. Parabola. But we're only looking from -2 to 1. X -2 y1. So we're only looking at the graph from these 2 points. You can almost erase the rest of the graph. I'm going to write this in red. So we're only looking at the red part of the graph. Don't look at the rest. We're only looking at the red part of the graph. So we want to find the slope first of these 2 points on the graph. Well, we know one of the points is, by the way, this is not a coordinate. This just says look at just that interval. We know one of the x coordinate is -2, and we know the other x coordinate is a +1. If I plug -2 into the original function, -2 squared is a +4. The y value equals 4. If I plug 1 into the original function, 1 squared is 1. So these are the 2 coordinates of those 2 points. Let's find the slope. This is my first point. This is my second point. This is x of the first point. This is y of the first point. X of the second point and y of the second point. So when I find slope, I should change my color. The formula for slope is y2 minus y1 divided by x2 minus x1. Y2 minus y1 divided by x2 minus x1. Y2 is 1. Y1 is 4. X2 is 1 and x1 is -2. 1 minus 4 is a -3. 1 minus a -2 is 3. So my slope is -1. And if you look at this red line, the slope is negative. So my slope is -1. I found the slope of those 2 points. At some point, I don't know where, I don't know how I can draw. I'm going to try to draw it like this. At some point, using calculus, I can find another slope between those 2 x values that has the same slope as -1. But I could only use 1 point because we're talking about a tangent line. So the mean value theorem says find the slope using 2 points, using calculus, use the endpoints. Then somewhere between those endpoints, you can find the same slope using calculus. Well, to use calculus to find the slope of this, we have to take the derivative. And the derivative of x squared is 2x. And once again, f prime is the slope, and we know we want the slope to equal -1, so I'm going to put a -1 here. Do you see? We want the slopes to be the same. We know the slope equals -1. F prime is the slope. If I divide both sides by 2, I know the slope is -1 at x equals -1/2. Do you see? At that point, that's -1/2. I know the slope equals -1 also. So that's what the mean value theorem says. We find this slope, and then we'll find the point on the graph, and it just happens to be x equals -1/2. If you want to find the y value, just plug -1/2 in here. The actual y value for that coordinate, -1/2 squared, is a +1/4. +1/4. Okay? That is the mean value theorem. So here's an example of the mean value theorem, a real world situation, and this really does hold true. If anybody's been to the state of Florida and driving out in the middle of nowhere, then a cop pulls you over, says you got a ticket, you're going 80 miles an hour. And then all of a sudden you tell them, I didn't see you. They said, oh, I didn't clock you. Our helicopter clocked you. And the way helicopters clock you in Florida is they put these two lines on the road and they time you from one line to the next. And using the time, they can tell your average speed. And as long as your average speed is higher than the speed limit, they will give you a ticket. I mean, even though you might have went faster than the average speed, but that's how they do it. If your average speed is higher than the speed limit, they'll give you a ticket. So this is very similar. Two police cars are 5 miles apart. Here's a police car, and here's a police car. They are 5 miles apart. Police car. I think that's supposed to be a little light police car. They're 5 miles apart. The first police clocks you at 55 miles an hour. You're going this way. So here they clocked you at 55 miles per hour. Here, when the police car clocks you, you went 50 miles per hour. Okay, I wasn't speeding. I went 55 when he clocked me, and the next guy clocked me at 50. But they also tell you it took you 4 minutes to go 5 miles. 4 minutes. So what they do is try to find your average speed. Rather than clocking you at 50, let's find the average speed. And this is very similar to what we just did. You know, if we have a curve, we want to find the average speed between 2 points. And then we're going to use calculus to find the speed at 1 point. So to find the average speed between these 2 points, remember velocity or speed of a car is miles per hour. How many miles did you drive? And how many hours did it take? Well, we know we went 5 miles. And we went in 4 minutes. Well, 4 minutes, if I want to change minutes to hours, I have to multiply 1 hour divided by 60 minutes. Minutes cancel down here, and we end up with 5 over 4 divided by, that's supposed to be a 60. 4 divided by 60. You see, we end up with 4 over 60 on the bottom. So on your calculator, type in 5 divided by 4 divided by 60. And when you put this in your calculator, I would put this bottom in a parentheses, and you get 75 miles per hour. Now, so this is basically, I mean, a graph of what we're talking about. Let me try to draw it over. Yeah, right here. Let's say I'm going 55 miles per hour, and then he clocks me at, well, I got to go from left to right. It's probably easier if we're looking at a graph. So he clocks me at 55 miles per hour, and then he clocks me at 50 miles per hour. And it says my average speed is 75 miles per hour. So somewhere between these 2 points, I have to have a spot that's 75 miles per hour. So in other words, the only way to get to 75 starting at 55 is by increasing my speed, not decreasing it. And then some point I decreased it when I got down to 50. And so we know this average is 75. At some point, our average was not our average, but there's a point on our graph that was 70. The slope or the speed was also 75. I could have went at 110. I mean, I would have to actually go faster than 75 to get an average speed of 75 because I was going less than it. So in reality, I was going 90 at some point, somehow faster than 75. But the police can only prove 75 because that's your average speed. Even though you went faster, they can only mathematically prove that you went 75. So you do get a ticket for 75. If you have 75 between the average here and you were clocked at 55 and 50, at some point you met more than 75 to get that average up there. And it says prove the car exceeded the speed limit. Well, your average is 75, and according to the mean value theorem, if you went 75 between, if you went 70, an average of 75 between 2 points, at some point on that, well, during that time that you were driving, you went 75 also. So that is how they give you tickets in Florida when they time you between two. They record your average speed and they give you a ticket for that. Even though you might have been going 90, you should be lucky or feel happy. They only give you a ticket for 75. And that's how the mean value theorem works. If anybody has any questions, feel free to contact me. Hope this video helped.